Okay. It's October 26th. We're going to record today. Are we ready?
Yes.
Yes. Okay. Today there is no review slide because you're working on that Section B packet. Tomorrow is the last day for the Section B packet. If you were not here, you're doing it during Ketchup and Pickle. Thursday and Friday, you're going to have a Section C packet that you're going to be working on. Both are going to be for a grade. Like I said, I will be picking and choosing different numbers for the grade. You won't get a grade on all of them, right? We talked about that. Mm-hmm. Then next week, Monday, we're going to go over the study guide. You're going to get your study guide and probably your study guide answer key on Friday. Monday, we're going to go over the study guide together. Tuesday, you have no school. Wednesday, we are going to take our Unit 2 test. My expectation, this is good to be on a recording. My expectation for your study guide is that if there is something on your study guide that you do not understand, you will go into your Google Classroom, like so. Here it is. You will go to classwork, and you will see all of the fractions daily videos. Every fraction lesson I have ever taught is right here. If you get that study guide and it says, put this fraction on a number line, then you're going to go right here to video number 6, where it says fractions on number lines. And you're going to watch what you need to watch in that video to figure out the answers on your study guide. Do you understand what I'm saying?
Yes.
All of my brain, all of my information, any fraction knowledge I have to offer you is right here in this list of videos. You can also find those on YouTube, right? Mm-hmm. Your study guide will be posted here, Unit 2 study guide and study guide answer key. And then your test answer key will be posted here when it's time for corrections. Okay? So you'll have both of these things. We'll have Unit 2 in them very soon. Does everybody understand what I'm saying about the fractions and the videos, how to use those videos with your study guide, all of that? Yes. All right. Then let's get down to business. Today's lesson starts here. Today, we are going to use equivalent fractions to compare. What is an equivalent fraction? What does that mean? What is an equivalent fraction, Jaden?
Something that's equal.
Something that's equal to each other, right? Can we come up with an equivalent fraction for 2/3? Chloe?
4/6.
How do you know that?
Because if you times the 2, it would equal 4, and times the 6 times the 30 equals 6. And like you say, is whatever you do to the bottom, you must do to the top.
Whatever you do to the bottom, you must do to the top. And when we multiply 2 halves like this, when we do this, what's this code for? Everyone? 1. Anything times 1 is itself, meaning the value of that number does not change. 2/3 and 4/6 is the same amount. If I had a Reese cup cut into thirds and a Reese cup cut into sixes, and I had 2/3 here and 4/6 here, that is the same amount of Reese cups. I would be happy to give Anna the 2/3 and I'll keep the 4/6. Or I'll give Anna the 4/6 and I'll keep the 2/3. I don't care. Why? Because it's the same value. It's the same amount of the best candy ever invented. Thank you. Listen to me, my friends. Listen to me, children that I love. Your peers have not done this today, but I'm asking you and you to do this. keep this thought process very, very fresh in your brain for today. This is what we are doing. Using equivalent fractions. Jaden told us that equivalent means they're the same. I told Anna she can have 2/3 or I'll take the 4/6, or she can have the 4/6 and I'll take the 2/3 because I don't care. It's the same, right? Because they're equivalent. We are going to use this strategy. We are going to use this strategy. I can't say it enough. Using this strategy to compare. When we compare numbers, we are deciding, is it greater than? Is it less than? Is it equal to? Or is it not equal to? These are the signs we're going to be using. And we're going to be saying things like this. 2/3 and 4/12. I want to find out which one's bigger. I'm going to teach you how to do that. Are you ready? Here we go. Let's compare fractions by writing. I'm sorry, can I say it again? Let's compare fractions by writing an equivalent fraction. Let me say it one more time. Let's compare fractions by writing an equivalent fraction, shall we?
Yes, we shall.
Please and thank you. What do you notice? What do you wonder? 30-second think time. Go. I'm going to take 2 notices and 2 wonder. I'm going to go notice, wonder, notice, wonder. Who's the first notice? What do you notice? Who's the first one? Gracie, what do you notice?
I noticed
Halves.
9 half is bigger than 4.5 half.
What do you notice about that? So you notice something about this guy here, right? We've never had anything like this. A whole number right next to a fraction. We'll talk about it. What do you wonder? I need a wonder now. Gabe, what do you wonder?
Why does it seem like 3 of those may be wrong?
Why does it seem like 3 of those might not be right? Right?
Mm-hmm.
Good. Now I want to notice. One more notice. Alea.
Oh, I noticed that 5 and 8 doesn't have the related.
No fractions here. What's up with that? Right? No fractions here. And one more wonder. One more wonder. Tucker.
I wonder why 4 holes is equivalent to 3. That's not equivalent to half. That's bigger than 1 hole. So it's one hole and one other tick. So it's not 4.
Huh. And you just wonder, what are they thinking?
Yeah.
I wonder what they're thinking. Right?
He just may have answered half of mine, actually.
Did part of his wonder answer part of your wonder?
Yeah.
Isn't it funny how that goes? Hold those thoughts, Gabe. We're going to talk. And you're gonna have a lot of talk time today if you keep up those thoughts. Here we go. Are you ready? Here's what we're gonna do. What does each statement say? We're gonna go back. Which of these statements are true, and which of these statements are not? And then why are they false? So let's go back. Let's go back. Here we are. Alea, can you read this to me? Five is less than 8. She read it. Leia, is that true? 5 is less than 8. If I have 5 Reese Cups and I have 8 Reese Cups, is 5 smaller than 8? Just 5 regular things, 5 whole things? Yeah. So is 5 less than 8? Yes. And that means that this first sentence is going to be true. This is true. Okay. Next. Everybody wants to call this 9 tooths.
9.
It's not teeth, guys. It's halves. It's halves. Anytime you see a 2 on the bottom, not talking about your pearly whites, okay? Which you should be brushing twice a day and flossing and or swishing. Swish those teeth. It's good for you. Not tooths, it's halves. It's not twos, it's halves. 9 halves. Who can read this to me? Logan, read this to me.
So 9 halves is bigger than 4 whole 1 half.
Okay, good. Close. 9 halves is greater than 4 and a half. This is 4 wholes and 1 half. What is a strategy we can use to, because now we have read it, 9 halves is greater than 4 and a half. We read it. Now, what can we do to determine whether this is true or not? Because do we know if this is true or not right now? We don't know, because 9 halves, what do we certainly know about 9 halves? It is what? It's greater than 1 whole, but over here, how many holes do you have? 4 holes and an extra half. What is something we could do to try to figure this out? Emma?
Maybe we could try like 2 to 9 pieces and there's 2 in the thing. We could try like 2 fours and 8 and then see how many holes we could make.
Emma. Everybody give Emma 2 big claps. Emma, this is beautiful. She's saying count by 2s because we know that the 2 is the total amount of equal parts. So how many equal parts do we need to make 1 whole, Emma? 2. So if I count, so have I made 1 whole thing and 2 equal parts here? Are you satisfied with that? So this is 1 whole, correct? And that gave us 2, correct? Is that okay? So then if I draw another one, how many halves is that? 2, 4, 6, 8.
And we have to stop there.
Now we have to stop there and just draw a half. 1, 2, 3, 4, 5, 6, 7, 8, 9. Does this drawing satisfy this fraction right here?
Yeah.
Yes?
But
Now what? Now what, Dominic? So we got this. Now we need to go over here. What do you notice about this drawing and this number right here? Talk to your table for 30 seconds. What do you notice?
I see what you're saying. And then there's the half. You see that? Yeah. 4 holes. Yeah, I see that.
Who's excited about their answer? Who's feeling like they've got something to talk about here? Jackson Pringle, I haven't talked to you yet today.
That just because there's a 4 there doesn't mean that that's a part of the fraction because there's 4 holes. And then also in that picture you drew there's 4 holes and then 1/2 right there, so they're equivalent.
Raise your hand if your table had that same conversation, that same realization. Look, I got 1 hole here. How many holes do I need? 4. 1 hole here, 1 hole here, 1 hole here. Does that satisfy the 4 holes?
Yes.
And then I got another half here. Does that satisfy the half?
Yes.
And so is 9 halves greater than 4 and 1/2? No, they are equivalent. Very nicely done. So that means this is
Equal.
but this statement right here is
False.
false.
They're the same point.
Did we prove why? Yes. Very nicely done, my sweet little children. Good job. Next here, read this to me. Who have I not talked to yet today? Remington, read this to me.
4 holes is equivalent to, say, half.
You know what I really love about what Remington said? Give Remington 2 claps. You know what I really love? He said 4 holes. He's noticing that this is not a fraction, that this is a whole number. And he's like, that's 4 whole things. So she's always talking about Reese cups. So that's 4 whole Reese cups. 4 whole things, so this says, is equal to 3 halves. Gabe Teal, you want to walk me through this? You want to help me figure this out? Told you you're going to get some talk time today. You want it? Here he goes.
Well, it's non-true.
He says it's false. Prove it, Gabe.
See, there are 4 holes.
Can I draw circles? Would that be okay?
Yeah.
How many do you want?
4.
Nice. Does this drawing satisfy this number, everyone?
Yes.
Yes, it does. Keep going, Gabe.
And on the other side with 3 halves,
Keep going.
you can see that 3 does make it to where it is over 1 hole, but it doesn't give all the way to 4 holes.
Can you help me draw a picture to prove that? Who agrees with what Gabe's saying? He says it is hands everywhere. It is over a hole, but it's not all the way to 4 holes. Gabe, we got to prove it, though. We can't just say that because just talking is not enough. Prove it to me.
So you would make 1 circle with a line to it so you can get the 1 hole. And then you would make a half of a circle to show the third part.
Now I have 1, 2, 3 halves here. Raise your hand if you agree with Gabe that this is false and this is why. Nice. Everybody give Gabe 3 claps. Good job. Ooh, those were some nice, good clapping. And finally, who's going to go here at the end? Izzy.
1/3 is less than 1/2.
That's what it says. Do you agree
Yeah.
or do you disagree? True or false?
I agree.
She agrees. Prove it. Tell me by.
You're gonna want to draw 3 circles to satisfy the 3. Do that.
You want 3 circles to satisfy the 3? Is it 3 whole things?
1.
1 circle.
Cut into thirds.
Can I do a tape diagram instead of circle?
Yes.
Circles with thirds
It's kind of hard.
is extremely challenging. How's that look, Izzy?
Yeah.
How many you want me to color in?
1. And now that satisfies the 1/3.
Okay,
And now make the same size diagram.
so I can't do this.
No.
Has to be the same size, correct? Who agrees with Izzy that this is not cool? It's ugly anyway, wasn't it? Needs to be it needs to be the same size. I'll do my best.
Yeah.
Is that fine?
And then you're gonna cut it like that right down the middle.
How's that look? Is that okay?
Yeah.
I'm not a computer, so it can't be perfect, right? Right? Okay. So, does Izzy's drawing prove that 1 out of 2 pieces, the alligator's eating it, is bigger than 1 out of 3 pieces? Is that right?
Mm-hmm.
Very good. Hey, y'all. Give yourselves a big woo-hoo!
Woo-hoo!
You worked hard on this and you did a good job. Did we read each statement?
Yes.
Did we say which ones were true?
Yes.
Did we say which ones were not?
Yes.
Did we say why they were true or false?
Yes.
We did. Very good. Okay. Before we begin this portion of our lesson, before we even get started, I want to go back here. This is what we do right here. This is what we do. Whatever you do to the bottom, you must do to the top. We do that to write our own equivalent fractions. That is why we do that. The object of today's lesson. Let's compare fractions by writing an equivalent fraction, shall we?
Yes, we shall.
I want to remind you of that so that when we get to here, you know what we are doing. It's a big one today. Just sit still. We'll fix that later. Here are some fractions you sorted yesterday. Do these fractions look similar to the fractions that were on that big chart? Yes, they are. Yesterday, we compared them to a half and to 1. Remember when we took this one and we were like, the half is going to be 6. We were right here. Sorry, online people. The half is going to be 6. I know this is bigger than 6. The half here is going to be 1.5. And this is bigger than that. So these are both bigger than a half. And both of them are smaller than 1. Remember that conversation we had yesterday?
Yeah.
Okay. What do the fractions in group 3 have in common? Look at these fractions. I'm going to give you a 30-second think time. Look at these fractions and tell me what they have in common.
You want us to do all of them on top?
Just group 3. Cameron, what do they have in common? All of them. What do they all have in common together? All 4 of them. Was yours just 2 and 2? Anna.
I'll go to so the first 2, which is 11/5 and 11/3, the numerators are the same, and the numerators are the same on the other side.
That's what you were going to say, isn't it, Cameron?
No, I didn't say that.
Okay. What do we notice about all of them together? Trenton.
That they're
Landon?
They all you add one more, like the top one, for example. 5 add another 5 makes 10, and 11 add 11. I think it equals that.
You're thinking good thoughts. Those are really good thoughts. He's like 5 and 5 is 10 and 11 is 1. He's thinking good thoughts. Those are good fraction thoughts, aren't they?
Mm-hmm.
It's not what I'm looking for, but those are really good fraction thoughts. Keep thinking those thoughts. Izzy?
Those two are both unequal.
Okay. I want something about all of these. Cole?
The numerator on the left one has 11.
Yes, but I want, yes, you're right. Yes. But I want something that's similar about all of them. Look at these. How many do you need to make a hole here? How many do you need to make a hole here? How many do you need to make a hole here? How many do you need to make a hole here? What's the same with them, Izzy?
They're all greater than 1.
They're all greater than 1. That is why they might be in the same group, because they're all greater than 1. How are the fractions in group 1 different than those in group 2? Look at these here. Let's just start with these. Let's do these. This one here and this one here. Remember yesterday we were talking about halves and 1, comparing them to half and 1. What's different with this one than these? And the same, if it's just these two, it's going to be all of them. Emma?
That one is one whole, and that one is greater than
1 whole? Or this one's not bigger than a whole. This is 2/3. None of them are bigger than a whole. Good. Jackson?
that group 1, hold
the table still, please.
they're all, in table 1, they're all less than 1/2, but in group 2, they're all over 1/2, but not 1. So it matches the questions that we got yesterday.
Very good. This matches from yesterday. Less than a half, more than a half, less than 1, more than 1. Remember we talked about that yesterday. That was the same situations as our chart, right? Right? Okay. All right. Now, we're going to come here. We're going to compare these. We're going to be thinking about halves and 1. We're also going to be thinking about writing our own equations. Okay? We're going to be thinking about halves and 1, and then we're going to be thinking about writing our own equations. So I want you to take, I'm going to change this here. I'm going to do this. Like I always do, right? Don't I always do that? And I'm going to put these circles here in the middle like this. And we're going to try to see about putting some inequality signs in there. Before we do that, I want you to take a 30-second think time about letter A at the very top. 2/10 and 26/100. Remember what we're doing here today. Writing equivalent fractions. Think. You have some thoughts now? You ready? 2/10 and 26/100. What do you think, Dominic? They're unequal. Why do you think they're unequal? Tell me more about that. I'm going to circle this instead. So you say, actually no. So you say they're unequal, right? Which one's bigger, Dominic? He thinks 2/10 is bigger. Let's figure this out together. 2/10, 26/100. When we compare fractions, the thing you need to be thinking about is common denominators. What that means is if I have a common denominator of, let's say, 12, if I have 3/12 or I have 8/12, which one do you think I might want? Trenton? 8/12, because 8/12 is greater than 3/12, right? So what you're saying is when I have the same denominator, it is super easy to tell which one's bigger and which one's smaller. Is that true? If all of these had the same denominator, could we get through these in a breeze? Shoot! If they all had the same denominator, this wouldn't take any time at all. But now we have 2/10. We know that 2/10 is going to be bigger pieces than the 26/100, but we're not sure how much bigger. So what if we were able to get common denominators, get the same denominator? Am I allowed to write an equivalent fraction to help me figure this out better? Yep. So what am I going to do? What am I going to do here to get the same denominator? Tucker?
You're just going to take away, for the 26, you just take away the 6 for the...
Then you're taking away 6 ones. You're taking away real stuff. Are you allowed to do that? Oh, I can't do that. Izzy, what do you think?
For the denominator on 2/10, you can times 10 by 10.
And that would get me from 10 to 100?
Yeah.
And then?
Whatever you do bottom, you must do to the top.
So what am I going to do 2 times? 2 times 10 equals 20. 10 times 10 equals 100. Now, which is bigger? 20/100 or 26/100? Cameron? 26/100 is bigger. And did I change the size of 2/10 when I made it into 20/100? No, I multiplied by 1. When we multiply by 1, we're just changing the name of the fraction. We're not changing its value, the size of it, its measurement, how much it really is, right? So our answer here is going to be 26/100. Can we do that same thing here? 2/5 or 11/100? Don't get fooled now, Dominic. Don't just think that the 100 is bigger because it's hundreds. Because, hey, look here. Listen. Look. If I have a circle cut in 2, or I have a circle cut into hundreds, which pieces are bigger, Dominic? The hundreds or the halves? Yeah. So don't let those big numbers fool you. Everybody's done that in every class so far today. They see that 100 and they're like, whoa, big number. Big money, big money. Well, it's not big money if it's
Smaller pieces.
smaller pieces. But we don't know because this is only 2/5. So maybe it is bigger pieces. How are we going to figure this out? What are we going to reason with ourselves to try to figure this out? What do you want to do? Tucker, what do you want to do?
Oh, you could do the same thing, but you could do it 20 times.
Do 5 times 20?
Yeah, because 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. That's 50. That's 10.
Okay.
50. 55, 60, 65, 70, 75, 80, 85, 90, 95, 100.
Is that 20?
Yes.
And then whatever you do to the
Bottom.
you must do to the top. So we can times this times 20. What's 2 times 20?
40.
40. Now I have 40 hundredths and 11 hundredths. Look here. I have 40 hundredths here and 11 hundredths here. Which one's more? 40 hundredths or 11 hundredths? 11 hundredths is more. How many pennies do you need to make $1? 100. So if I got 40 pennies or 11 pennies, how much money? Which one is more money? 40. So 40 hundredths or 11 hundredths, which one's more money? Good job. 40. Don't get discouraged. You're doing great. This is hard stuff. This is tough. There's a reason why I've had to record every single block. And I'm finally, you know what I'm saying? This is hard stuff. I'm not asking you to do super easy stuff. You're doing great. You're doing great. Now, hey, let me ask you a question. What if I did, I'm going to bring this over here. What if I did this? If I did it times 10 and I got 50ths, would that have shown me that this was going to be more? That would have shown me if I wanted to do it that way. So if you were thinking about comparing with 50ths, you can do that too. Group 2, 2/3 or 7/12. 2/3, 7/12. Which one's bigger? How do we know? What can we do? Cora, what do you think we can do to find out which one's bigger? When we compare fractions, the object of today's lesson is to write equivalent fractions to compare. What equivalent fraction can I write, can I create to make it easy to compare? What denominator could I go to? Can I use a 3 to get 12?
Mm-hmm. Yes.
Yeah.
Mm-hmm. Yes.
How many 3s do you need to get 4 or to get 12, Cameron? Cora? Sorry. 4. So 3 times 4 equals 12. Whatever you do to the
Bottom, you must do to the top.
2 times 4 equals 8. So, Cora, what I'm trying to say is that 2/3 and 8/12 are the same thing. So if 2/3 and 8/12 are the same thing, which is bigger, 2/3 or 7/12? But 7/12 is bigger? Well, 2/3 is equal to 8/12 because 2 times 4 is 8 and 3 times 4 is 12. So if 2/3 is the same as 8/12, which is bigger, 8/12 or 7/12? 8/12. And 8/12 is the same as 2/3 right here. Right?
So 2/3 is larger than 12.
Yes, that is correct. That is correct. Next one. 4/5 and 7/10. How are we going to change 4/5 to make it easier to compare with 7/10? Jaden?
7/10 is
Hold on, wait. We're going to change this. Jaden, how many 5s do you need to make 10? 2. So you're saying that 5 times 2 equals 10. Is that true? Yes. And so, Jaden, whatever you do to the... So what am I going to put here? I got a 2 here. Whatever I do to the bottom, I must do to the top. What am I going to do here? 2. It's not going to work. It's not equivalent. You're right. It would equal 8/10. So that tells me that 4/5 is the same as 8/10. So what does that mean? If 4/5 is the same as 8/10, then which is bigger? 8/10 or 7/10? And so which one do you want the alligator to eat? 4/5. Who agrees with Dominic? 4/5. Very good. Okay? Sure? All right. Are you guys understanding what we're doing now?
Yeah.
Are you seeing what we're doing?
Yeah.
Mm-hmm.
All right. Brentley, you said yes. You ready to lead us through this next one? Give it a go, my man. Be brave. Be strong. 11/5 and 26/10. What do you want me to do here, Brentley?
Do write a line, like right in the I want to do 5 times 2 equals 10, but I can't do that because I can't do it to the top.
Hold on. What is it? 11/5?
Mm-hmm.
You want to do 5 times 2 equals 10 to match here and here, right?
Yeah.
And now you're saying you want to do 11 times 2, but you're saying I can't do that because it's not going to be a match, right? I'm not asking you to make a match. I'm asking you to tell me which one is bigger or which one is smaller. So it's not going to be a match because they're going to be different sizes. So 11 times 2 equals 22. And so that means, Brentley, that 11/5, since 11/5 is the same as 22/10, 11/5 is going to be bigger or smaller than 26/10. 11/5 is bigger?
No, smaller.
Why do you say that?
Because the denominator on 11/5 is smaller than the denominator on 10/26.
Well, listen what we've just done. This is the whole point of this lesson. We have changed 11/5 so that it doesn't mean 11/5 anymore. We have decided that we have said figuring out 11/5 and 26/10 is too hard because I can't figure it out. I don't have enough information. I can't draw that. I'm not a computer. I can't draw it just right. So we have said to ourselves, fine, I'm going to get rid of the 11/5. I'm going to rename that same fraction because I know that if I have, let's use 2/3. 2/3 and 4/6, those things are the same. I'm allowed to change the numbers if I want. I'm allowed to change the name of the fraction if I want. So, Brentley, you have said 11/5. I can't compare fifths and tenths. I don't know which one's going to be bigger or smaller. So what I'm going to do instead, I'm going to give this a new name. I'm going to multiply it by 1, 2 halves. That's going to change it from 11/5 to 22/10. Now I can disregard all this, and now I can say 22/10 and 26/10. Which one's bigger?
22/10.
Huh?
22/10.
If I have 22/10 or I have 26/10, the 22 is going to be bigger. It's all tenths. It all looks like this. It's all this size of pieces. It's all this size of piece. If I got 22 of these in this hand and 26 of these in this hand, I got more over here. It's all tenths. We've made it now so that it's all tenths, so that it's easy to understand. It's all tenths. It's easy we're trying to make this easier to compare. They're all cut into the same size piece. Now I got 26 in this hand and 22 in this hand. Which one's bigger, 26/10 or 22/10? 26/10 is going to be bigger. And here, we've done all this math over here to come over here and say 11/5 is less than 26/10. That's what all this math over here does. So now let's do one more together before it's time for you guys to go. Let's do one more. 11/3 and 26/12. 11/3, 26/12. You want some think time? Mm-hmm. Dominic's asking for 30 seconds of think time. Go ahead. Take your think time. We're right here. This red box. Okay. What do you notice? What do you notice about 11/3 and 26/12? Can we compare those things?
Mm-hmm.
11/3 and 26/12?
No.
I don't really know what that looks like. I don't really know what that means. But if I had the same denominator, then would I have a better idea about what it looks like?
Mm-hmm.
Can I get the same denominator?
Yeah.
Talk to your table for 30 seconds. Get the same denominator in 30 seconds. Talk to your table.
Wait, I know.
Get your things. You're going home.
Okay. Oh no. Slide on that. Get kicked out of here.
What'd you guys come up with? Did you talk to your table? You had your 30 seconds of think time. Did you talk to your table about anything? Emma, what do you think?
We talked about
Emma talked about 3 times 4 equals 12. Does that help us? Hold on a second. Does that help us? If we got this to be 12, would that help?
Yeah.
Whatever you do to the bottom,
You must do to the top.
what's 11 times 4? Everybody?
44.
44. So now I've got, hold still, please. Now I can get rid of this stuff. I can cross that out and say 44/12 is obviously bigger than 26/12. And since 11/3 is the same as 44/12, which is going to be bigger, 11/3 or 26/12? Izzy? 11/3 is going to be bigger.
Or 44/12.
44/12 is the same thing. This is how you write an equivalent fraction to compare with another fraction. You have to look at these numbers here. You have to look at these denominators and think to yourself, how are these related? What can I do with these fractions to make them the same? What can I do with these denominators to make them the same so that I can compare them properly? That was the whole objective of today's lesson. I hope you guys will take that to heart. I love you very much. That concludes our math class for today. I will see you later.